So here is another question. So we have to determine the decimal values of the given signed binary numbers in 2's complement form. It is expressed in 2's complement form. So the first number is 0111 and then 400000. The second one is 1001 then 4 zeros 00. So the first step, as usual, is assignment of weights. 2 to the power 7, power 6, power 5. They're all 8-bit numbers. 4, 3, 2, 0. Okay. So the first signed binary number is 0111 followed by 4 zeros. Here, first step is designation of the sign bit. The sign bit is 0. So it is a positive number because sign bit is 0. Then we have to multiply the weights with their respective 1 bits and then add them together. So it will be the decimal value 1 into 2 to the power 6 plus 1 into 2 to the power 5 plus 1 into 2 to the power 4. So 64 plus 32 plus 16. So 64 plus 32 is 96 plus 16 is 112. So plus 112. Okay. So it's obvious because the sign bit is 0, so it's a positive number, decimal number. Next, the other signed binary number which is given. Again, first step, assignment of the weights, the respective bit positions. 6 power 5 to power 4 okay, it's 2 to the power 4, power 3, power 2, power 1, power 0. Okay, and the binary number is given 1001 and then 4 zeros. Then checking the sign bit, it is 1, so it is a negative number. Okay, the sign bit is 1, so we have to assign a negative weight to it. The decimal value will be minus 1 into 2 to the power 7 plus 1 into 2 to the power 4, and there are no other 1 bits, so just this much. So minus 128 plus 16, so it is equal to minus 112. So if you see, here it is minus 112, and the previous one, the decimal value was, we calculated, it was plus 112. So from this we can draw the conclusion that this binary representation, signed binary representation, is the 2's complement of this one, this. Okay, because here it is plus 112, here it is the negative minus 112. So obviously they are 2's complement pairs. So again, through visual, from the visual representation, it is very difficult to determine whether they are 2's complement pairs or not. Just when we check it through weight assignment and then adding the values, we get, okay, this is negative, this is positive. So in 2's complement case, it's better that you go with the usual process, the lengthy process. Whereas in 1s complement, just by looking at the bit representations, if it is inverted bits at the respective places, then they are 1s complement of each other. But in 2s complement, you have to double check. Okay, so this is the thing. See, the point here I'm trying to make here is that, see, these binary numbers, here it is 01111 0000, here it is 1000 1111. Here it is the same 01111 0000, here it is 1001 0000. You have to identify the relationship between these pairs, okay? These, okay? This one and this one, this one and this one. Now, if you just watch carefully these two binary representations, the bit patterns, you will see that this one is the 1s complement of this one. Why? Because at the respective bit positions, zeros and ones, they are interchanged. Here it is 0, here it is 1, followed by 3 ones, here it is 3 zeros, here it is 4 zeros, here it is 4 ones. So we can say these are 1s complement pairs. Each one is the 1s complement of the other. Now, here, if we take this 1s complement, that is 1 000 1 1 1 1, and we add a 1 to the LSB, that is, we are trying to determine the 2s complement. So then we have 1 plus 1 0 with a carry of 1, again 1 plus 1 0 with a carry of 1, again 1 plus 1 0 with a carry of 1, again 1 plus 1 0 with a carry of 1, then 1, then 0 0 1. So we have 1001 followed by 4 zeros, which is exactly this. So this is 2s complement pair. But just by looking at these binary representations, these two binary representations, this one and this one, okay, when we look at these two binary representations, just by looking at them, we cannot figure out for sure whether these are 2s complement pairs or not. But when we look at these two binary representations, this one and this one, we can figure out for sure that they are 1s complement pairs, because the bits are inverted at their respective positions, they are interchanged. So it is easy to identify 1s complement pairs, but it is difficult to identify 2s complement pairs. So it's better that you double check when it comes to 2s complement binary representations. Okay, so this is the